So I guess we are live. Yeah. Hello everyone. Welcome back to another video of AI SageMaker series. So we are doing an AI project on AWS SageMaker, and till now we have done a lot of work. We have trained our model. We have generated the XGBoost training report as well as the profiler report here, and we have learned how to we can create the link in the previous video. Also in the morning video, I we have done we have converted deployed this model, and we have provided some parameters into it, like I only want one instance because that is sufficient for me to deploy my model. And I deploy provided the instant type and as well as the serializer, as my data is in the CSV format, and I get the endpoint on which my model is get deployed. Okay, so now let's move ahead, and that is the final stage. Today is the last video of this series. So in this video, we are going to evaluate the model which we have deployed to this SageMaker hosting service endpoint, and we will evaluate and use this model into the production environment. And to use it, we have to invoke the endpoint with the test data set. That's why we segregated in the very first place into test, training, and the validation data set. Test, train, and validation we already use. Test is remaining. So we are using that to invoke that endpoint and check whether that inferences you get returned a target accuracy we want to achieve or not. Okay. So first, what we do, we split our large data set into chunk to avoid it should not exceed the payload size limit. Okay, and we because and then make prediction for each of those chunk, and then again we will concatenate that result. Okay. So first we are splitting that data set, then putting each chunk and make prediction using that, and then in the end we concatenate the result. Why we are splitting, because we don't want to exceed the payload size limits. Okay, so for first that I have to import the numpy library. Okay, so press shift enter to execute it. So this is we done, and then I'm going to define a new function. Okay, and here I'm going to input my data, and I will put rows as 1000. So what is this rows specify here? It specify the number of lines to predict at a time. Okay, so I want it should predict 1000 line at a single time, my model to predict it, and the data is the which I'm going to providing the input as. Okay, then let's define this function. Okay, so first what we will do, we will split the, as I said, split the input data into chunks of size, which is we have specified by the rows parameter. Okay, and this is useful when we are making prediction on large data set especially, and generally we working with the large data set in our organization, and this help us to avoid exceeding this payload size limit. Okay, so what will I do? I will like create a variable split array. Okay, and then I will split it, and I will provide the input of my data, and then I will define the parameters for it. So for particular rows which we have defined, that is 1000 at a time, it can execute. Okay, and can increment one by one. Okay, I hope it is clear now. And then after like so this array split array which we have defined here. And now so this is like clear, we are basically splitting all those data which we are providing, which we are getting from here in the set. We are providing that as input, we are like splitting that it and incrementing it one by one. So we will get the new data, and it will take 1,000 rows at a time, single time, as an input, and like predict what will be, like this is that person's income is going to be more than 50,000 or not. Okay, because this is a binary classification model basically. So binary classification, why it is? Because it has only two answers, like in the binary form. Like the person can have more than 50,000 of salary, or person cannot have it. That is true or false we are looking for. Okay, and it is basically doing the classification. So that's why we are utilizing it. Now we what we will do, we I will make a like an empty prediction. Okay, so here I'm going to put my like whatever the result, I'm going to use it in this variable. So I will define it as an empty. And then what will I do? I will want to like iterate over the chunks of the, because I have splitted my data set into different chunks to avoid that limit load. So I will like iterate over the chunks of it. So to iterate it, of course, we are going to use the for. Okay. So for array in split array. Okay, so basically this line specify that it we want to iterate over the chunks of the input data which we are providing. Okay, and then here I'm going to use predictions, because I have already defined it earlier. And then I will uh, like what will I do? I will call the predict method on this my XGB predictor object, and which is the like endpoint which I defined in the previous line. If you look at here, so here when I deployed my model, I have defined this XGB predictor variable. Okay, so what will I will call like basically I will specify that particular object. I will call this object the predict method, and to obtain that prediction from the current chunk. Okay, so for every chunk it is going to perform predict that, and in the last, what we are going to concatenate that prediction from each chunk with comma as a separator. That's why I put as a comma here. And then I will utilize this join command. Okay, not command, like join functionality. So join, then I have to provide the predictions here, which are made for each chunk. If it is iterating for every array or for every chunk of data which we are like in the test data set it is providing. So it will do that. And now I'm going to call this, where I will copy this. Okay, so and then I'm going to predict it using this model and provide my array here. So every chunk of data will come here, and the model will perform its functionality, and we will get it. And then as we like this result can be in a float format, like it will give you maybe 0 0.1, 0 0.2, 0 0.3, something like this. But we want it as an binary classification, that is either true or either false. So basically to do that, we have to like decode this binary response from the predictions into an UTF-8 string. And later what we will do, we will convert these prediction string into NumPy array series using a comma as a separator. Okay, so to first we will to decode this binary response from the prediction to into UTF-8, we are going to utilize the decode functionality. Okay, so we are going to decode, and then I want to decode in UTF-8. Okay, So I hope this is clear, and after doing that I want to finally return all this np from string predictions. We have got it, and then one by one, and we want to separate it uh, by comma. I guess that would be fine. Okay, so this last line basically converting all these concatenate prediction strings, including the initial comma which we provided, and say uh, into a numpy array. Basically, we are doing that and using comma as a separator. So this is what we want to return. Okay, so let's execute it using Shift and Enter. Okay, so it is successfully executed. Now what we will do, we will create histogram of this prediction. So for that we have to like import our matlab, so that will help us to create and display an histogram of the prediction which we have obtained from the predict function. Okay, so what I will do, I will import matplotlib. Okay, and then I'm going to use pyplot. Shift enter, and then I'm going to call that function of predict. Okay, test to numpy. Okay, somehow language changes. Okay, so what I am doing here, I am calling the predict function on the test data set. So and this I am obtaining an array of the prediction here. Like here I'm trying to like calling that test data set and obtaining an array of the prediction using this. Okay, and now what will I do, I will to create an histogram of this prediction. So I'm going to utilize the his function from the matplotlib.py plot library, and this histogram represents the distribution of that whatever the model has predicted the value. So for doing that I'm going to uh, like first, okay, we are getting some error here. Predict. So why we are getting b, let me execute it. Okay, there is issue with this np. Okay, which we are getting, but I guess okay, here I defined as py, so let me define it as np because I generally define numpy as in that. That's why it is giving error. So yeah, now it is a string or file cannot be read due to its unmatched data. This will raise value error in the future. Okay, yeah, that's why we are utilizing this UTF-8 and because we are decoding it, so it's not an issue for us. Because we are going to plot it as an histogram. Okay, so I will use it and like predict it. If I going to predict it, press Shift Enter, and you can see we get an histogram of that, and or you can either use this functionality as well. Okay, so you can see there is like 0 1 0 1, so which shows us the result of the true false and true false and all. Okay, it basically displayed the generated histogram. This is the cannot be read due to it and due to unmatched data. This is the yes, yeah, we are doing the correct one. Okay, so after we had done this, we can see there is an generated graph, which we can see here, and wait, so let me, if I execute it together, we are still getting the same. Okay, so this is our we have got graph. Now what we will do, we are going to evaluate the perfectly. There are two like common tools which we are going to utilize it. First is the confusion matrix. So this is a very popular term in the AI and ML terms. And second is the classification project. Okay. So if you guys have any doubt, please let me know in the comment section so I can explain you what it is. So confusion matrix is basically provides us an tabular for summary of the model's performance, showing us the count of the true positive, true negative, and okay, let me show this on your screen so it will be more clear to you guys. Okay, wait, I guess you are able to see that screen. So yes. So this, as you can see, this confusion matrix is basically a tabular summary of this model performance. So it shows you four values. First is true positive, true negative, false negative, and then false positive and true negative. So what does it represent actually? So true positive represent the instances that which model correctly predicted as positive. Okay. So means it was a it suppose if the income was greater than 50,000 and predicted it correctly, and it was greater than 50,000, that is the positive value, and it predicted it correctly. Okay, so that is true positive. And true negative means when it correctly predicted as negative, means the salary of that person is less than 50,000, and which is the negative value, but it has predicted it correctly, yeah, this person has less than of income of 50,000. Okay, then there is false positive, which is like when model does not give the correct result and predicted as positive, and which are like basically true, means incomes are basically more than 50,000, but it is not able to correctly predict that. And similarly for the false negative, when uh, like instances incorrectly predict as negative. Okay, so these are also known as type 1 error and type 2 error. And based on these four parameters, you can calculate the accuracy of the model. You can calculate the precision of the model. These are the formulas. I will provide the link to of this blog into the description, uh, and you can just calculate all these out. Then there is a recall value of that model. You can find the specificity, or that is true negative rate, and F1 score also, which is like the true. These parameters are the like very important when you are evaluating the performance of that model. Okay, and the second report is the classification report. So this classification report directly provides you these additional metrics to give you a more detailed view about the model performance, and that is, we discuss precision, recall, and F1 score. So instead of providing all these only four parameters, it can directly provide you this precision, recall, and F1 score. Okay, so I will we are going to actually implement it. And so like this precision basically is the ratio of the correctly predicted positive observation to this total prediction. And as you can see from its formula, that is true positive, that is means what is labeled as true, and it is predicted that correctly with the like divided by the total true results. It is because whatever it is predicted correctly as well as incorrectly. So basically that is known as precision, which is like a very scientific term. If you have done engineering or something like this, you already know all these terms. Okay, so this can give you a more classified like more provide you these additional metrics by itself. Okay, so what I'm going to do, I'm going to show you by practically doing it. So let me just show it to you guys. Okay, so let's come to our screen. I hope it is visible to you guys, the screen. So first I'm going to import the sklearn library. Okay, so till I have done that, now what I will do, I will set a threshold value for converting this probability prediction into binary prediction. Okay, because like my result is basically what I am predicting. I am predicting the income. That income is more than 50,000 or income is less than 50,000. So I want this value like true or false. Okay, so that's why I have to set a threshold value to convert into a binary prediction. So predictions greater than the cutoff which I'm going to set are classified as one, that is true, and those who are less than equal to cutoff are classified as zero, that is false. Okay, so because model can give a result into a float, that is 0 0.1, 0 0.2, so that will considered as false only. That means that person's salary is less than 50,000. So I will here set my cutoff as 0 0.5. Okay, so that is the I hope you understand the cutoff issue. And then what I will do, I will I can directly print this confusion matrix and classification report. So to print all these classification reports, simply we have to use this print functionality, and then utilize this sklearn library, and we will call this matrix into it. And firstly we will generate the confusion matrix. Okay, that provide us the value of true positive, true negative, and then false positive, false negative. Okay, so for that I'm going to call it and then provide my test data into it. And then I have to provide the location from which I wanted to take it. So I, I have taken it from the start. So basically here what I will do, I am providing like how to compute the confusion metric using these true labels which I am providing and the binary predictions. Okay, so for the binary predictions I also have to apply the cutoff threshold as well to convert these probability predictions into binary predictions. Okay, so because I only just putting it out in a variable this cutoff, but I have to actually implement it. Okay, so to actually implement it, I have to put it here and utilize the numpy library here. So where I have to put the cutoff here when wait Yes. Yeah, my predictions is where my predictions is greater than cutoff 1. Okay, so I have clearly specified like where I want to apply that like how I want to create my confusion matrix. So I can do that and just okay. We are getting some issues. sklearn we test.ilog. So whenever you get any error, don't be like worry. It is just an like you just figure it out what the error you are getting, and you can simply uh, utilize it, and it will also give you a more in-depth knowledge about it. So it is good that you are getting these errors. Okay, found in put variables within consistent number of samples. Okay, so I guess we skip some commands. So maybe because of that we are getting this issue. So let's try to execute it all together. Okay. Similarly, like just we done for the confusion metric, we have to do for the classification report only. Just the we have to define the two different metrics. Everything will be same. Okay. But the issue here we are getting is that from this line and it is asking for these two. Is it because like I have done it yesterday? It is taking a different value because I have performed it before this video and it was running fine. Value error and this check consistent length. Found input variable with the where we are importing. Okay, let's do it again. I guess we missed something. So it is going to our classification.py file and the y type binary multiclass. Let's check targets y true. Okay, the y level and the s level it is showing us issue. But anyway, it can you can like these are the commands which you can do. It is, I guess it is because just now I run it, so like again I cannot use that particular endpoint to generate it. So that is like not an issue. So we can after we done all these like we have done with the evolution, we can like we have to clean up whatever we have done so we don't get the much cost on this AWS side. So for doing that we have to go to this our SageMaker endpoint. So come to your SageMaker and go to this SageMaker, and here you can see these multiple options here. Okay, so in these options, first thing you need to notice that this training jobs and the logs you cannot delete and cannot be deleted basically, and they are going to retain indefinitely, but they are they don't cost you that much, or like they don't cost you money. Okay, so what you have to do, you have to delete the resources which can cost you money. So you have to go to this inference section basically, and here you can go to this endpoint. So basically you have to click here and go to this and just delete this. Okay, so this you need to follow, otherwise it will going to cost you a lot of money and you get a rigorous bill from the AWS. Okay, after that you are done with this, then come to this end point configuration and also delete this as well. Okay, and then go to this models which we have created and delete the model as well. Okay, and finally we have to delete our notebook instance which we have created at the very first lecture. So just select this and click on so like you can see we are not getting this delete. So with the notebook instance, until you stop that, you cannot get this like a delete option. So just click on stop and it will go into status of stopping. It will take some time, several 5 to 10 minutes, and it will reload it. Also, like our model artifact is in the S3. So go to S3 and go to buckets. You can like see this all will be like gone soon because we have clicked on the stop. So you don't need to worry about it because we are going to delete every set of that. Okay, and also you have to open. Okay, so we have got this, and let's open CloudWatch as well into a different tab. Okay, so I have opened the CloudWatch into different tab. So here is my bucket. So I have to delete it, and as you know, to delete it, first you have to empty it because if I click on delete and so it says bucket is not empty. So it is required whenever you delete an S3 bucket, you first have to empty it. Okay, and it says you have to type the permanently delete here. Just click on empty. So now it is empty and it has been successfully deleted. But now if I go and click on delete, I will be able to successfully delete it. We have to type the name of the bucket, click on delete bucket. So it has been successfully deleted. And in the CloudWatch section, you have to come to this logs page. Okay, and go to this log group. So you can see all this AWS/SageMaker. So select all this, click on action, delete log groups. Just click on delete. So this is all done. All log groups has been deleted. Also check the EBS section as well, which is the part of the EC2, that is volumes, EBS volumes. If it is anything is there. So currently we don't have it. And also check the EFS. So make sure you check everything. We don't want to get ourselves to be built for unnecessary resources even we are not using that. Okay. So this is like basically enclosure of it. And let's go to our SageMaker and see if our notebook instance has been deleted or not. So to SageMaker. Okay, and come to this notebook instances. Okay, it has been stopped. So now after it is stopped, you can see in the action you can delete it. So click on this delete and it will delete all your Jupyter and everything. You can see now we are getting this server connection error because it has started deleting it. Okay, internal server kernel died, etc. So there will be multiple things will happen. Okay, so also if you want to download this one, you can just click on download. Now it will be not because we have deleted, but before that you can download it if you want. And so there is no EFS, so let's close it. And the SageMaker, it is currently in the deleting stage and it will be going be deleted soon. Okay, so that's it in this series. So some ability has connected with us. So yeah, hello ability. Like, do you have any question? Okay, that's all in this video. We are talking about if you guys have any doubt related to artificial intelligence, machine learning, deep learning, generative AI, or any of the cloud service provider, AWS, Azure, Google Cloud, or you want to know how to prepare for these interviews, please let me know in the comment section. I will try to help you and let you know if you can see this. Okay. So I suggest everyone if you are putting out something in comment, please wait for some time because there might be some delay in the video process. Okay. Okay, so that's all in this video. Make sure to subscribe the channel, like the video, and watch my all other videos for more detail. And I will keep making all these series, so make sure to subscribe the channel and see you guys in the next video. Thank you.